we are supposed to discuss in this video. Direction says read the information given below and answer the questions that follows. Each of 6 runners A, B, C, D, E, F participated in a race which had 2 events, R1 and R2. Now, at the end of the event, each runner was given a position in each of the 2 events from 1 to 6. The runner who was the winner got first position and the runner who finished at the end got the 6th position. So guys, we have 2 races, right? 2 races are given to us, race 1 and race 2. And the number of participants are A, B, C, D, E and F. And using these hints, we are supposed to determine the ranks of each of these 6 persons in race 1 and race 2. All right. So basically, we are supposed to find out the ranking here. It is also known that for any runner, the sum of the position of that runner in the 2 events is not an even number. Now, that's a very, very important information that you need to interpret it. You just don't read it and move forward. No, need to understand how does it make sense, how this information is related to the table that we are trying to fill. What information that you can infer from this statement that the summation of both of these 2 ranks should not be an even number. Now, how do you find the summation of 2 values as an even number? Either both of the numbers should be odd, then I'll get the summation as even, or even plus even will also be equal to even. Now, the summation of both of the ranks should not be even. That means one of the rank has to be odd, the other rank has to be even. If one of the rank has to be odd, the other has to be even. That means both of these 2 ranks for a particular person should be different. That means if I am giving a rank 2 to B in R1, I cannot give 2 to B in R2 because in that case, both of these 2 values will become 4. So both of the ranks are different. That's the point that you need to infer from the first statement, which is a very, very important one. Now, second statement says B finished later than C in race 1. Now, in race 1, okay, race 1, race 2, A, B, C, D, E, F. B finished later than C in race 1. So just use this information, B. So if B is finishing later than C, that means rank of B will be lower than C, right? When I say the lower in terms of magnitude, the rank of B would be higher than C, right? Right? More is the magnitude value of the rank. That means you are finishing the race later. The person who will be finishing the race who will be winning the race will be ranked as 1 as per the statement here. So B is finishing later than C. That means C is the first, C is coming, C's rank must be, in terms of magnitude, must be lower than the rank of B, right? The difference in the position of A in R1 and the position of D in the race R2 is 2. The difference in the position of A in R1, so if I say the position of A in R1 is X and the position of D in race R2 is, let's say, Y, then the difference of these 2 values, that means X and Y, has to be 2. Which value will be more in terms of magnitude? That's not given. Simply it says the difference has to be equal to 2. X can be more than Y, so that you can say the magnitude of X and Y would be equal to 2. X can be more than Y or X can also be less than Y. C, who was third in race 2. Now it's given that C was third in race 2, got better position than at least 3 runners in race 1. Now C's rank is better than at least 3 positions. So that means there are at least 3 persons who will be finishing the race after C. At least 3. There can be more than 3. That means there will be at least 3. Now, when I say that the C rank is at least the 3 persons, which are the minimum number of people who are finishing the race after C, can I say the rank of C cannot be 4? Because if I give rank 4 to C, that means 2 people will be finishing after C. But because it says 3 people are there, at least 3 people are there who are finishing the race after C, the possible option for the rank of C will either be 1 or it would be 2 or it would be 3, right? Either it would be 1 or 2 or 3. It cannot be 4. Now observe it. Can I put 1 here? If I put 1 here, 3 plus 1 will be 4. So 1 is not possible for C, right? Is it possible for, can I put 3 here? If I put 3 here, 3 plus 3 will become 6, which is an even number. So 3 is also eliminated. Can I say there is only one possible option for C, and that is 2, right? So the rank of C in race 1 will be 2, right? So we get this information, right? All right, let's move forward now. What else the question says? C who was 13. Okay, we have used this information, statement number 4. Let's read the next statement. D who was at a worse position than at least 3 runner in race in the R1 race was at a worse position than E in R2 race. Now this is an information that says D who was at a worse position than at least 3 runner. D who was at worse position in at least 3 runner. That means the number of people in race 1 who are finishing the race before D are at least 3. The minimum value is at least 3. That means there are minimum 3 number of people who are finishing the race before D. So the rank of D, the possible option for rank of D, because there are 6 people who are participating, at least 3 people are finishing the race before D. So rank of D can be either 4 or 5 or 6. It cannot be 3, because in case you give rank 3 to D, then 2 people will be finishing ahead of D. We need at least 3. So the possible option for the rank of D would be 4, 5 or 6. Right? So the value over here for D can either be 4 or it can be 5 or it can be 6. Was at a worse position, or the same line is talking about D again, was at a worse position than E in the R2 race. Was at a worse position than E in R2 race. In the race 2, the rank D is finishing after E because the rank of D is worse than E. That means D is finishing after E, right? All right, let's move forward. F was 4th in race 1. F was 4th in race 1. This number is 4 and was at a worse position than D in race 2. F is finishing after D in race 2, right? So because F rank is given over here as 4, can I eliminate the option of D having the rank of 4, right? So we will be left with these 2 cases. D rank will be either 5 or it will be 6. Now one information that we are yet to use is this one. And you can also see that if B is finishing after C, the possible option for the B rank would be either 3 or it can, 4 is already there, 3, 4, 5, 6. These are the possible option for B because B is finishing the race after C, right? Let's see now. Now let's use this information, the difference in the magnitude of the rank of A in R1 and the position of D in R2 is 2. X minus Y has to be 2. Now, if I write down the 6 numbers, 1, 2, 3, 4, 5, and 6, and if I'm supposed to find out the pairs in such a way that difference has to be 2, the possible option is 1 and 3 is a possible option, 2 and 4 is a possible option, and 3 and 5 is possible, or 4 and 6 is possible, right? 1, 3, 2, 4, 3, 5, and 4, 6. All of these pairs have a difference of 2. Now, if I am putting 1 here, then to make a difference of 2, I need to put 3 here. But 3 is already used, so this is eliminated, right? So can I say 1 cannot come over here, okay? What if I take a value of 3 and 1? So can I take 3 and 1? If I put 3 here, to make a difference of 2, I need to put 1 here. This is again eliminated. Why? Because D is finishing the race after E in R2. So can I give 1 to D? No. 1 rank to D is not possible, right? So you need to eliminate this case, right? So this case will be eliminated. That means 1, 3 as a combination which have a difference of 2 is eliminated. Now let's pick the next case, 2 and 4. If 2 is not possible here, if I give 2 here, then 2 is already used by C. So 2 is not possible. What if I give 4 here? If I give 4th rank over here, then I need to give 2 rank over here, right? 4 and 2, that's a possible option, right? 4 and 2 will give you a difference of 2. Okay, let's keep this, right? We'll decide later whether this will be eliminated or not. Okay, what if I have to take a 3 and 5? If I give 3 to x here, then I need to give 5 to y here. Now D is getting a rank of 5. Okay, that's a possible option. Okay, but if I give 5 here, then I need to give 3 here. 5 and 3 will not be possible because 3 has already been used. What about 4 and 6? 4 and 6 are also at a difference of 2. 4 cannot be used here, 4 has already been used. Now this case is also eliminated. If I'm giving it 4, I need to take 2 here. 4 has already been used by F, so can I eliminate this particular case, right? So 4 is not a possible option here, so you need to eliminate here, right? 4 is not possible, right? Then you have only this option, 6 and 4. If I go this as a 6, then I need to give 4 here. Will it work? This is a possible option. This can work, right? 6 and 4 have a difference of 2. 3 or 5 have a difference of 2. So we finally come down to 2 possible cases. If I want to maintain a difference of 2 between A's rank in race 1 and D's rank in race 2, the possible option are 6, 4 and 3, 5. All right. Then do we have any other information about A? We don't have any other information. Okay. B finished later than C in race 1. Okay. And the difference in, we are using this, C who was 3rd in race 2 got better position than at least 3 runner in race 1. We have sorted out this issue. D who was at a worse position than at least 3 runner in race 1. Okay, was at a worse position than E in the race 2. Okay. Okay, F was at a 4th position in R1 and was at a worse position than D. F was at a worse position than D in R2 race. F was at a worse position than D in R2 race. Now see that if I give a rank 5 to D, let's say these are the 2 cases I have. If I am taking 6 here, 4 here, then if I'm taking 3 here, then I'll be taking 5 here. Now see that if I am taking 5, if a case of 3 and 5. Now to make F worse than D, I need to give a rank 6 to F. Now 6 plus 4 will become 10 and the summation will become an even number. So you need to eliminate this case. That means this cannot work. 6 cannot come here. If 6 cannot come here, that means 5 cannot come here. If 5 cannot come here, that means 3 cannot come here. So that means 6 and 4 will be the possible case here, right? So 6 will come here, right? 6 will come here and 4 will come here. So we get to know these 2 ranks will be 6 and 4. Let's fill this information. This is definitely 6 and this is definitely 4. Right. Okay. Now this is 6, this is 4, right? And now I want the summation of both of these 2 values to be an odd number, not an even. So 6 will be eliminated here. So the only possible option left here would also be 5. 5 will come here, 4 will come here. Now 5 and 6 are already used. So I'll be left with only these 2 cases, 3 or 4. But 4 is already used. So the only option for B rank would be 3 here. So the B rank in race 1 would be 3 here, right? So 2, 3, 4, 5, 6. The only rank that is left is 1. So 1 will come over here. Now, F rank is worse than D. F rank is worse than D. So if D rank is 4, F rank will be either 5 or 6. If I put 6 here, 6 plus 4 will become 10. So F only option left is 5. F would be given a rank 5 here, right? And okay, let's talk about E. Now, the rank of E is better than D. So D is 4. So the only option left here is 1, 2 and 3. 1 is already here. So 1 cannot come here. 1 plus 1 will be an even number. 1 is here. 3 cannot come here. 1 plus 3 will also be an even number. So the only option for E is to put 2 here. So the only option for E is to have a rank 2 in R2. So this number will be R2. Now I need to put 1 here also, right? 2, 3, 4, 5 rank has already been decided in R2. I need to put in both of these two options 1 also. 3 plus 1 will be 4. Summation cannot be an even number. So I need to put 1 here. And the only rank left is now 1, 2, 3, 4, 5, 6. 6 will come here. That's it. The grid is completed and now you can answer all the questions. This is how you're supposed to solve a ranking based question in races. That's the concept. You just need to interpret the statement, use some of your number skill. You need to be comfortable with the numbers. Your quantitative reasoning skills will be really, really helpful in the ranking set. And CAT is keen on these type of set where they might ask you set on ranking, because in the previous year papers, right, you will find a number of sets which are completely based on the ranking concept. Here is the direction, here are the direction. Let's quickly solve this set. It says a tea taster was assigned to rate teas from 6 different locations: Munnar, Wayanad, Ooty, Darjeeling, Assam and Himachal. These teas were placed in 6 cups, number 1 to 10, not necessarily in the same order. The tea taster was asked to rate the teas on the strength of their flavor. On a scale of 1 to 10, he gave a unique integer rating to each tea. Some other information is given below. So after reading the first paragraph, you get to know that this set is basically to find out the rating of tea and also the state of the tea. There are 3 variables that this set is talking about: the cup number of the tea, the state of the tea, and the rating of the tea by the tea taster. And the rating is from 1 to 10. This is one thing that you need to take care. And there are total 6 different type of teas. So 6 different state and 6 cups number. And these are the information that we are supposed to know, or that we are supposed to solve. So you straight away start with writing down the cup number, right? So can I write down the cup number 1 here? So that 2 points, right? First, in the first column, you write down all the cup name: 1, 2, 3, 4, 5, and 6. And then we will finally organize, right, this complete information, right? We need to make a small table, right, telling us that in which cup, right, in which cup which state tea is present and what is the rating of that tea. So we are supposed to find out the state of the tea and the rating of the tea. These are the 2 variables that we are supposed to find out, and we have this information to complete the table. Okay, do we need to complete the table? That depends what type of information is available to us, right? So let's straight away start filling in the information in the table. The first question says cup number 6 contain tea from Himachal. So straight away I can write down the name of the state here. The state name is Himachal here, right? So this name is Himachal, right? Okay. Tea from Ooty got the highest rating, but it was not in cup number 3. So cup number 3 did not get the highest rating. What is the highest rating? It can be any number from 1 to 10. We do not know what is that highest rating, right? Obviously, if there are 6 cups, the minimum possible highest rating is 6. The maximum possible highest rating can be 10. So it can be any number from 6 to 10, but we do not know that highest rating is what number. This is something we need to find out. And what we can mention over here is tea from Ooty got the highest rating. So just keep this information, right? Just take it as a highlighter, right? Just highlight this information that the tea from Ooty got the highest rating and it was not in cup number 3. So can I say the cup number 3 does not contain the tea from Ooty, right? So just straight away write it down like this, right? Cup number 3 does not contain the tea from the Ooty. The rating of tea in cup number 3 was double the rating of the tea in cup number 5. So if the rating of the cup number 5 was X, the rating of the cup number 3 will be 2 times of X, that is 2X, okay? Only 2 cups got the rating in even number. Now this is a very important information, that 2 cups got the even number rating. Can I say that one of that cup will definitely be cup number 3 because this is 2 times of X. So this is definitely going to be an even number. Cup number 3 will definitely be an even number. So there is one more cup which will be having a T rating as an even number. Okay. Cup 2 got the minimum rating and this rating was an even number. Now the second cup which contains an even number as a rating of T is cup number 2, and I need to write down that this cup number is also have an even rating and it got the minimum rating, right? Now the minimum even number can be 2, 3, 2 or 4 or 5, but we can straight away say that this number can definitely be, cannot be 6, because if I take this number as 6, right, this number is the minimum possible rating. So 6 is definitely not the case. There are only two possible cases, because if this number is an even, it can either be 2 or it can be 4, right? Cup number 2 can have a rating of 2 or it can have a rating of 4. Okay. What else is a possible case? And also you need to take care that this number is having a minimum rating. This number is having a minimum rating. So just write down the word minimum here also, right? This is having a minimum possible rating. Only 2 cup got the rating. Okay, we have used this information. We have used the information number 5 also. Look at the information 6. Tea in cup 3 got a higher rating than that in cup number 1. So cup number 3 rating is higher than the cup number 1. Okay, we will use this information later. The rating of tea from Venard was more than the rating of tea from Munnar, right? So tea which belonged to Venard is more than, the rating of the tea from Venard is more than the tea from Munnar, and but less than that from Assam, and but less than from Assam. So that means Venard rating is less than that of Assam but more than that of Munnar. Okay, now let's start filling in the information. We know that this number is definitely not an even number. If this is not an even number, then there are two possible cases here, that this number will either be 1 or it will be 3, right? Why it can't be 5? Because if you take it as 5, then this will be 10, and if this is 10, this will be the highest rating. But it is specifically mentioned that the highest rating is not in cup number 3. The rating of tea in cup 3 was double the rating of tea in cup 5. Tea from the OT got the highest rating, but it was not in cup 3. So cup number 3 is not having the highest rating, so I cannot put the value of 10 here. So therefore the only possibility for cup number 5 is to have the rating of 1 and 3. Now if I put 1 here, then this value will be 2, then this become minimum, right? And minimum rating is cup number 2. So 1 is also not the possible case. So if 1 is not coming here, that means 3 is coming here. So straight away I can mention these two values, that if 1 is not coming, 3 will come here. If 3 will come here, then the value that will come over here will be 6, right? So now let's write it down. So this is rating 3 and this is rating 6. All right. What about cup number 2? Now cup number 2 has two ratings, either 2 or it can be 4, and both it has to be minimum. Now you see that if I put a value of 4, then it will not be a minimum rating, because then 3 will become minimum. I need to keep the rating of the cup number 2 as minimum possible. So therefore out of 2 and 4, I will choose the option of 2, because that is less than 3. So therefore I also get to know that the rating of cup number 2 is 2, right? So the rating of cup number 2 will be 2, right? Okay, so these are the three values that we get to know. Now tea from the Uti got the highest rating, right? That Himachal is coming over here, so Uti cannot come here. Uti cannot come here because Uti is getting the highest rating. So there are only two options left for Uti. It can either be cup number 4 or it can be cup number 1. These are the only two options left. Do we have any other information which is telling us that where we can place the OT? Let's have a look at it. Tea in cup number 3 got a higher rating than in cup number 1. Now you see that this information can tell you tea from OT got the highest rating, and OT is not in cup number 3, and rating of 3 is more than the rating of 1. So if rating of 3 is more than rating of 1, that means one cannot have a tea from the state OT. Because if cup number 1 have the tea from the state UT, the rating has to be highest, which is not possible. So therefore UT can come only at one place, and that place is cup number 4. So UT will come over here. This has to be the highest rating. Okay, what will be that highest rating? It has to be an odd number and it has to be more than 6. So there are only two possible cases, that it will have the highest rating of 7 or it will have the highest rating of 9. Right? Okay, and we also need to make sure that the rating of cup number 3 is more than the rating of cup number 1. If we have 6 here, and we know that their number here will come as odd. So if the odd number is supposed to come at in front of cup number 1, it can only be 1, or it can be 3, or it can be 5. Now 1 cannot come here. Why 1 cannot come here? Because The minimum rating is cup number 2. So 1 is eliminated. 3 cannot come here because 3 is available here. So this is also eliminated. The only option left for cup number 1 is the rating of 5. So therefore, cup number 1 will have the rating of 5. So this value will be equivalent to 5. Okay. So let's write down this value. Cup number 1 will have the rating of 5. Okay. Now we are left with this value, Himachal. Now Himachal, we have the information. Let's use the information. The T from Uti got the highest rating. Okay, so it has to be cup number 4, but it can be 7 or 9 both. You see that if I place a value of 7 over here, let's say if I'm placing a value of 7 here, then you see that for this particular cup, I don't have any option left. I will have the option of either 1 or 3 and 5 are already placed over here. So only option left for Himachal is 1 because even number cannot come over here. But 1 cannot come here because in that case, the minimum rating will be in the cup number 6. The minimum rating is already mentioned, it's cup number 2. So therefore, the only option left for Himachal to have an odd number is 7. So if 7 comes over here, then the rating of the cup, rating of the tea, which is from the Uti is 9. So therefore the value 9 will come over here, right? So therefore 9 will come here, right? And 7 will come over here. All right. So you see that these are the states name: Uti, Himachal, and Assam, Wennar, and Munnar. We do not know, and no more information is available. It can be, placed in these 4 places in any order, right? We do not have any other information except this, so we'll have to keep it on hold, right? And yes, no other information is talking about the state, so just keep it on hold. We know the state of Himachal will be here, Uti will be here. Assam, Wennar, Munnar, and Darjeeling. These are the state names that we cannot find in this case. We need more information for that. But let's see, do we require this information to answer the question or not? If you look at the first question, what was the second highest rating given? The second highest rating given, you see that the first highest rating is 9, the second highest rating is 7. I don't require this information of state to answer my first question. So the answer to this question is 7, right? The answer to this question will be 7. Now let's look at the next question. Question number 2. Question number 2 says, what was the number of the cup that contained tea from Uti? We already know that the number of the cup that contains tea from Uti, you see that cup number is 4. So the answer to this question is cup number 4. So 2 questions can be answered without using the information of states. So we don't need that information to answer the first 2 questions. Now these are the 2 questions of this set. That question number 3 and question number 4 will be discussed in the next part of the video. And you try to give the answer to the question number 3 and question number 4 now that we have made a table, a small table, right? Let's see. The third number table is about the state, and state information is not unique, but try to use this information which is given in the question. Using this information, is it possible to answer the question or not? Try to do that. So here is question number 3 and here is question number 4. These are the 2 questions which I will be discussing in the next part of this video. Very easy. I'm sure if you try this set, you will definitely be able to solve it. So I would request all of you to give it a try. Read the instructions carefully. To solve this set, you don't need to understand high level reasoning. It's a basic, right? It's a basic set. Anybody can solve it if you just read the information properly. Anybody can solve this set. It says Healthy Bites is a fast food joint serving 3 items: burgers, fries, and ice creams. It has 2 employees, Anish and Bani, who prepare the items ordered by the clients. Preparation time is 10 minutes for a burger, 2 minutes for an order of ice cream. So note down this timing, guys, right? So if you want to prepare the burger will take total 10 minutes to prepare. And then an ice cream will take 2 minutes to prepare. An employee can prepare only one of these items at a time. That means an employee cannot prepare burger along with ice cream at the same time. So either an employee can prepare a burger or employee can prepare the ice cream. Now the fries are prepared in automatic fryer, which can prepare up to 3 portions of fries at a time and take 5 minutes irrespective of the number of portions. So up to 3 portions, the fryer will take 5 minutes. So even if I have to make 2 portions, fryer will still take 5 minutes, right? So at a time, a fryer will be able to make 3 portions and that will require 5 minutes of time. But it does not need any attendant. The fryer does not need an employee to constantly attend to it. And we can ignore the time taken by employee to start and stop the fryer. That means to make the fries is no time that is required basically, only machine is working. Thus, an employee can be engaged in preparing other items while the frying is on. However, fries cannot be prepared in anticipation of future orders. Healthy Bites wishes to serve the orders as early as possible. The individual items in any orders are served as and when ready. However, the order is considered to be completely served only when all the items of that order are served. That means at a particular time you can order only one order, right? Wishes to serve the orders as early as possible. The individual items in any orders are served as and when ready. However, the order is considered to be completely served when all the items of that order are ready. The table below gives the order of 3 clients. So the client number 1 order is placed at time 10 and he ordered 1 burger, 3 portions of fries, 1 order of ice cream. Client number 2, time is time 5. The second order is coming from client number 2 and the time of the order is 10:05 and then you have 2 portions of fries, 1 order of ice cream. Client number 3 is placing an order at 10:07 with 1 burger, 1 portion of fries. So that's the information that you have. Now, very, very easy question, guys. It will not even take 10 seconds to answer, right? So I have put the main part, the table here, right, to solve the question. It says, assume that only one client's order can be processed at any given point of time. So Anish or Bani cannot start preparing a new order while previous order is being prepared. So if you want to serve the client 2, you first need to serve the client 1. So the 2 employees that this food joint has first have to serve the orders of the client 1, all the items of the order 1 of client 1, and then they can switch to client 2. So, and 2 employees, Anish or Bani, are there. So question is asking me at what time is the order placed by the client 1 completely served. See that? I mean, why will you take this? Not even require any kind of thinking. You can straight away look at the question and answer it, because it says that burger can be prepared in 10 minutes. 3 portion of fries will be prepared by the machine and that will be taken 5 minutes. There is no attendant that is required. And 1 order of ice cream will take only 2 minutes. Now, because I have 2 employees, so 1 employee between Anish or Bani can make a burger in 10 minutes. And then the second person, let's say Anish is making burger, and if he start preparing the burger at 10, so can I say by 10:10 the burger will get ready? And if Bani is preparing ice cream, she will take only 2 minutes. So by 10:02 the ice cream will be ready, right? By 10:02 the ice cream will be ready. Now the order is completed when you have served all the items of that order. So all the items of this particular order will be prepared by 10:10. Before 10:10 you cannot serve the complete order because burger will not be ready. And portion of fries will be prepared by 10:05 and there is no attendant that is required, right? It will be the machine that will be working. So tell me the time and at which you will be able to give the client 1 order completely. You will be able to serve the order by 10:10. This was the question of CAT 17 slot 1. Anybody can do it. Anybody. Very simple. Question number 2. It says that so assume that only 1 client's order can be processed at any given point of time. So Anish or Bani cannot start preparing a new order while preparing previous order while previous order is being prepared. At what time is the order placed by client 3 completely served? So I just want to see that the order of client 3 will be served by what time, right? So Anish and Bani cannot start preparing a new order while previous order is in place. So see that I know that the order 1 will be placed not less than 10 minutes, right? So by 10:10 all the items of the order 1 will be ready. So by 10:10 client number 1 will be served. Now to serve the client number 2, once this order has been completed, Anish and Bani start working for order number 2. Now 2 portion of fries will take 5 minutes. That means by 10:15 the order of fries, 2 portion of fries will be ready and that will be made by the machine, and this will take only 2 minutes by any of the employee. So by from 10:05 to 10:07 you will be able to make the ice cream also. But the complete order will be served by 10:15. So by 10:15 the second order will also be served. Sorry, by 10:15 the second order will also be served, right? Now you see that to serve the third order you need to make 1 burger. So by 10:15 you will get free yourself from this order number 2. So when you start making the burger, let's say Anish started making the burger at 10:15. So by 10:25 the burger of order number 3 will be ready, and 1 portion of fries can also be ready from 10:15 to 10:20, right? Because that will be the work that will be done by the machine. Nobody is required. So by 10:25 the burger will be made. So the complete order will be served by 10:25. So the third order will be served by 10:25. So client 1, client 2 and client 3, all 3 orders will be completed by 10:25. That's the correct answer to the question. A very simple question, right? You see that these 2 questions were free marks for CAT 17 slot 1, right? Previous to this video, I did one more set of CAT 17 slot 1. It was based on chess tournament, right? That set was also easy. So if you do 4 questions of that chess set and 4 questions of this set, these 8 questions will take you to 90 percentile, right? So you just need to solve one more set to cross 95 and one more set to cross 99. So at least these 2 easy set, right? You first need to reach at 90 percentile to reach 99, right? So if you solve these 2 sets in the first 10 or 15 minutes, I guess both of the 2 sets, the chess set and this particular set, can be solved in 10 to 15 minutes, right? And then in the rest of the 40-50 minutes, you can easily do 2 more set of moderate level of difficulty. Also, there's a root and network based puzzle that I have uploaded in the previous video. You can also have a look at that. This one is a tricky question to solve. Let's have as it says. It says, suppose the employees are allowed to process multiple orders at a time, but the preference would be to finish orders of client who placed their orders earlier. At what time is the order placed by client 2 completely served? So in the previous question that we did, a particular employee cannot work on the multiple orders unless all the items of the previous orders are served. But in this particular question, it says, suppose the employees are allowed to process the multiple orders at a time, right? That means if somebody is working on ice cream and that ice cream will be prepared in 2 minutes, but the burger will be prepared in 10 minutes, but the employee who is working on the ice cream will be free by the time burger is prepared. So that employee can work for the further order, right? In the previous question, in the previous 2 questions, and it was given to us that a particular employee cannot serve the items of the next order unless the items of the previous order are served. Now, if you have to take this condition into consideration, how will you solve the question? Now, the question is asking what is the order placed by the client to completely serve? Now, see that 10:10 burger, it will take 10 minutes for the burger to be ready, and we have 2 employees, right? Let's say Anish is working on burger, right? One of the employees, Anish, let's say Anish is working on in making burger of the first order. So that will take that order will be completed. The burger will be made by 10:10, and the fries will be made by 10:05 by the machine. And the order of ice cream will be prepared by the Bani, and the Bani will be able to prepare this order in 2 minutes. So Bani will be free by 10:02 from the order number 1, from the client number 1. So Bani is free by the time burger is ready. By the time burger is getting ready. So Bani can now start working on the order number 2. But can Bani start working on the order number 2 unless it is placed? Even though she is free at 10:02, but she cannot start working at 10:02 on order number 2 because order number 2 was placed at 10:05, not at 10:02. So by the time the second order is placed, that is at 10:05, now Bani can start working on it. Now 2 portion of fries will be made by 10:10 by the fryer machine. No attendant is required. And the order of ice cream this order of ice cream will be made by the Bani at 10:07, right? The question says, suppose the employees are allowed to process the multiple orders at a time, but the preference would be to finish the orders of client who placed their orders earlier. At what time is the order placed by client 2 completely served? Now, the order made by the client 2 will be completely served once the order of the client 1 is done. And this particular order can be prepared by 10:07. So you see that, but will you be able to serve this order before the client 1 is served? See, earlier it was given that employee cannot start working on the next order unless the order of the previous item is served. But here in this question, the condition is that the preference will be to finish orders of the clients who place their orders earlier. At what time is the order placed by client 2 completely served? So if your preference is to complete the order of client number 1, which will be done by 10:10, by 10:10 you can also make sure that the client number 2 order is also ready, because the earliest time by which you can make the order of client number 2 is 10:07. So by the time you serve this order, at the same time you can also serve the order number 2. So the the order of the client 2 will be completely served will be 10:10. That would be the correct answer of the question. Now let's have a look at the question number 4. It says that suppose the employees are allowed to process the multiple orders at a time, but the preference would be to finish orders of the client who placed their orders earlier. Same condition as of the previous question. Now the question says also assume that the fourth client came in only at 10:35. Now between 10 and 10:30, for how many time is exactly one of the employees ideal? Now we are supposed to find out that time period where either one of the employees is working. So between Anish or Bani, either Anish is working, Bani is ideal, or Bani is working, Anish is ideal. What is that total time duration where one of the exactly one? See that? It's not that at least one. It says that exactly one of the employees is ideal. Now, let's see that. Let's say Anish is working on this order by 10:10, right? So Anish will be busy till 10:10. Okay. And this will be made by the machine. And this order of ice cream will be made by 10:02 by Bani. Now, Bani, you see that, will be free at 10:02. And because the next order is getting placed at 10:05, so Bani will start working on the second order at 10:05. So can I say that Bani is completely free from 10:02 to 10:05? Yes, Bani is completely free from 10:02 to 10:05, right? And then when Bani start working on this order, right, Bani again will be making the ice cream from 10:05 to 10:07, right? So Bani will be busy from 10:05 to 10:07. And this will be made by the machine. No person is required to make this order. Now, third order will be placed at 10:07. Now, Bani is free at 10:07. So Bani will start making this burger at 10:07 and she will complete this order by 10:17. And the order of fries will be made by the machine. So 10 by 10:17, Bani will be busy from 10:10 to 10:17. But you see that at this point of time, Anish is completely free at 10:10. So Anish is completely free from its order at 10:10. So from 10:10 to 10:17, Anish does not have any work to do. So Anish will be free from 10:10 to 10:17. So total you see that, right? And after this, after the 10:17, Anish and Bani both will be free. But the question is not asking me the time at which both of them are free. Question is asking me the time at which exactly one of them is free. Either Bani is free or Anish is free. So therefore, you see that this is a 3-minute time where Bani is free, and this is a 7-minute time where Anish is free. The total time where exactly one. Keep this in mind. I'm trying to make you understand the meaning of the word exactly one of the employees ideal. Exactly one, that means either Bani, Anish is working, and then Anish is free, Bani is working. So that total time is 10 minutes. So the answer to the question will be option number 2. That would be the correct answer of the question. Right? Okay. So these are the 4 questions. You can see that the questions of all this, of this complete set were very easy. Anybody can do it, right? So set is not difficult. The selection of the question is very important. You need to select carefully, easy set in the first 20-minute, 15 minutes period. And if you can catch on with these type of sets in the first 10 to 15 minutes, you can easily get through with the LRDI section, guys. Thank you so much for watching the video. Here, this is a set that we are going to cover. The Humanities Department of a college is planning to organize 8 seminars, one for each of the 8 doctoral students, A, B, C, D, E, F, G, H. So these are the students, 8 students, and 4 of them are from economics, 3 from sociology, 3 from anthropology, 1 from anthropology department. Each student is guided by one among P, Q, R, and RSNT. So the 5 professors and 4 subjects and 8 students. P, R, and T are guiding 2 students, and Q is guided by each of Q and S. And 1 student is guided by each of Q and S. Each student is guided by a guide belonging to their department. Now, each seminar is supposed to be scheduled in one of the 4 consecutive 30-minute slots starting at 9 a.m., 9:30 a.m., 10 a.m., and 10:30 a.m. So we have 4 slots. We have 4 slots, 4 subjects, 8 students, 5 professors. And with the number of students in economics, 4 of them are from economics, 3 from sociology, and 1 from anthropology department. So you need to make a table, guys, right? Look at the number of look at the different components here. I have to decide the slot in which a subject is happening, in which the guidance of a particular subject is happening. I'm also supposed to tell in that particular slot which student is guided. I'm also supposed to tell that particular student is guided by which professor, and I'm also supposed to tell that student belongs to which department. So these are the components. So how to make a table, you need to decide that. It's always better to start with the time slot, because 4 time slots are fixed, and we know that first slot, the first session definitely will be happening at 9 a.m. So make a table, right? First session will be happening at 9 a.m. So 9 a.m. the first slot, right? The second slot is 9:30. See that this order cannot be changed. So this order of the slot is definitely fixed, because 9 a.m. will obviously come before 9:30. So it's better to start with a fixed component, and because the time slot is definitely fixed, so let's start 9 a.m., 9:30 a.m., 10 a.m. and 10:30 a.m. Let's write it down in the table. And now look at what is the next component that is fixed, and that's subject. So let's write down the name of the subjects. I have 4 students opting for economics, right? 3 students opting for sociology, and 1 student is opting for anthropology. So we don't have 4 subjects, we have 3 subjects: economic, sociology, and anthropology. Now, let's use these information. Let's use these information to find out the complete solution. All we need to do is just fill in the information in the table, and we'll get the answer. Now, more than 1 seminar can be scheduled in a slot, provided the guide is free. Only 3 rooms are available, and hence at the most 3 seminars can be scheduled in a slot. This is an important information, that in a particular slot, maximum number of seminars that can be conducted are 3, not more than 3 rooms are available. So only 3 rooms are available. So that's a point that you need to use. This will really help you in completing the table. Students who are guided by the same guide must be scheduled in consecutive slots. Students who are guided by the same guide must be scheduled in consecutive slot. Okay. For example, if P is guiding, it's given that P is guiding 2 people. So P, both of the persons or both of those 2 people which are guided by P must be in consecutive slot. Similarly, R is also guiding 2 persons, so both of the person who are guided by the R must be in the consecutive slot. T is also guiding 2 persons, so both of these 2 persons or both of the 2 slots must be consecutive. Then Q is guiding only 1 person, S is also guiding 1 person. First information says seminar by students from economics are scheduled in each of the 4 slots. Now, if I have to use this information in the table, in each slot, one economic seminar is being conducted. So can I say at 9 a.m. there has to be one economic slot, 9:30 also. There has to be one slot at 9:30 for economics also. Economic is also happening at 10. Economic seminar is also happening at 10:30. So that's the basic information that you need to use, right? Right. So use it. One economic seminar is happening in each of these slots, and we have 4 economic seminar happening. We need to decide the student and the professor name that we will be deciding later on once we get through the more information, but that's how you are supposed to use this now. Now next it says A is the only seminar that is scheduled at 10 a.m. and A is guided by R. So at 10 a.m. there is only one slot that is happening. There is only one seminar that is happening, and that is of A, and A's professor is R. That means no other seminar can be conducted at 10 a.m. This is the only seminar that you can conduct here, right? Okay. Now let's use the next information. F is an anthropology student whose seminar is scheduled at 10:30 a.m. F is an anthropology student whose seminar is scheduled at 10:30. F, we have this anthropology, right? F is an anthropology student and F seminar is scheduled at 10:30. Okay. And now we also know that there is only one student of anthropology. It's given that 4 of the students belong to economics, 3 from sociology. So economics we have 4 students, sociology we have 3, and anthropology we have only 1 student. So can I say that there cannot be any other seminar of anthropology? So anthropology seminar is happening at 10:30. Student is F. We need to decide the guide name, right? That we will be deciding in a minute, right? Let's use the further information. Now, because we know that R is conducting 2 seminars, so can I say that either, and because R is guiding A and A is an economics student, so can I say R cannot guide F? R is an economics teacher. So, and both of the lectures or both of the seminars conducted by R has to be in consecutive slot. So R will come over here or R will come over here. R cannot come in this particular slot, right? Why? Because of this information that that the students who are guided by the same guide must be scheduled in a consecutive slot. Now let's use the information further. The seminar of a sociology student is scheduled at 9 a.m. Okay, there is a one seminar at 9 a.m. of sociology students. So let's say this is the sociology seminar happening at 9 a.m. Right? All right. So because this seminar has happened already over here, so can I cross these values, right? This seminar is has been conducted over here. Now we are left with these spaces. Okay, we need to decide the time slot of these 2 sociology lectures now. Rest of the things have already been sorted out. Now look at it. B and G are both sociology students whose seminar are scheduled in the same slot. Use this information. B and G are supposed to come in the same slot and both of them are sociology students, right? The seminar of an economics student who is guided by T is also scheduled in the same slot. That means along with B and G, I also need another person, another student who is guided by T and that person is of economics. So that means I have 3 seminars being conducted in a one slot. 2 of them are of sociology, 1 is of economics. Both of these students are B and G and economics is guided by T. We don't know the student's name here. And then P, who is guiding both B and C. Now, because B is a sociology student and B is guided by P, so we can say that P is guiding a sociology student, so P must be a sociology teacher. And P is guiding both and C, and P, who is guiding both B and C, has student scheduled in the first 2 slot. Now, both of the student of P, which are one of them is B and another one is C, has to be scheduled in first 2 slot. Now we get to know that B and G are supposed to be together along with the one economic students, and they are supposed to be in first two slot. Now, if I look at this table, I need to make B and G in the same time slot, and both of these two time slots has to be the 9 a.m. or 9:30 a.m. So you can see that either I need to take these two as the sociology students in this time slot, or these two, right? It will not matter. Or both of the sociology students has to be at 9:30, and both of these students are B and G. Now, one of the case has to be there, right? So if I'm saying that, let's say B and G, both of these students are sociology students, and the seminar of these two students are happening at 9 a.m., then along with one economics, this must be T. This must be a lecture which must be guided by T. And then I also need to make sure that C is also guided by and B is being guided by P, and P is guiding B and C both. C must be coming in the consecutive slot. So can I say that this must be of C and P, right? This must be the slot allotted to C, which is guided by P, because B and C is supposed to be together. Now, look at the next information. It says A and G are scheduled in the two consecutive slot. Now, A and G are scheduled in the two consecutive slot. Now, see that A is already there. If I put B and G over here, G and A are not consecutive, right? So, the moment I look at the next information that A and G are scheduled in the two consecutive slot, I can get to know that if A is already there, G must be coming over here, right? So, this case will not work. B cannot come over here, right? B and P will definitely be coming, B and G will definitely be coming over here, so that G and A can be consecutive. Now B and G will come here. This person must be guided by T, the economic teacher, and B and C are both sociology student and guided by P. So can I say this must be C and this person must be guided by P. Now these two values can be crossed, right? So these two lectures are happening at this slot now. Okay. Now we got two consecutive lecture of P, right? R is an economic teacher, so he must be guiding one more person, and that student must be of economic. And because this person is guided by T, so can I say R lecture are supposed to be consecutive? This person must be guided by R, so that both of them can be consecutive. And also T is also guiding two students. Both of these two time slots should be consecutive. If this person is guided by T, can I say that this person also must be guided by T? So this must be guided by T, right? Now, that's the complete information that we have now. Is there any other point that we can use? We have used this point. A and G are scheduled in two consecutive slot. P, who is guiding both B and C, has student schedule in the first two slot. This information is also used. Now E, one of student along with B and G is guided by T, that is also used. Now we get both of the lectures of P, we got both of the lectures of T, we get both of the lectures of T. Now we are left with Q and S only. So can I say G must be guided by either Q or S here? We don't know who will be guiding G, right? And similarly, this person F, who is an anthropology student, must be guided by Q or S. That's how you're supposed to make this basic table, and you're supposed to answer the questions now. Let's look at the question number 1. Which one of the following statement is true? इसमें से कौन सा statement सही है? Which one of the following statement is true? Only one seminar is scheduled in the second slot. Let's check. No, in second slot we have 3 seminars. 3 seminars scheduled in the last slot. In the last slot, you can see that we have only 2 seminars. 3 seminars are scheduled in the first slot. In the first slot, we have only 2 seminars. 2 seminars are scheduled in the first slot. Yes, 2 seminars are scheduled in the first slot. So the answer to the first question is option 4. That's the correct answer to the question. Now let's move to the next. Who all are not guiding any economic student? Who all are not guiding any economic student? You see that? Economic students, you can see, are guided by T and R, right? All 4 economics teachers are students are guided by T and R. So T and R are economic students. Question is, who all are not guiding any economic students? So can I eliminate all the options which are which have R or T. This has R, eliminated, eliminated. This also have R, eliminated. So the answer is third option, PQS. Which of the following statement is necessarily true? Q is guiding G. See that we are not sure. Q is guiding G. Q can be guiding G. Q can be guiding F also. We don't have any information to decide who is the guide of G. So this will be eliminated. H is an economic student. H is an economic student. Yes, we are left with, you see that, out of all the people, right, we are supposed to tell whether H is an economic student or not. You see that H cannot come over here, right? H cannot come over here. So we have only 3 spaces left for H. H can come over here, or H can come here, or H can come over. So wherever H is coming, H is definitely an economic student because all 3 spaces left are economic slot. So can I say that? Yes, H is definitely an economic student. So the second option will be the correct answer of the question. Now let's move to the question number 4. The question number 4 says, if D is scheduled in a slot later than Q. Now D is scheduled in a slot later than Q slot. Now Q is a professor, right? And D as a student is having a slot which is later than Q. Then which of the following statements are true? Then we are supposed to tell which of the following statements are true. Now to answer this question, I need to use this information. The D slot must be coming after Q. Now you see that for Q I have only 2 options. Either Q will be coming over here or Q will be coming here. So if I'm saying that D schedule is later than Q, so can I say that this slot will be belong to Q? Because if I say that Q slot is this, then I cannot have a later slot for D, right? So if I want D to be scheduled later than Q, then Q must be coming over here. If Q is coming over here, then this slot must be of S, right? This slot must be of S. Okay. And now because D is supposed to become later than Q, here I have A already. So the only slot left for D is this one. D must be coming over here. Okay, now if D comes over here, the 2 people that I'm left with is H and C and H. So these are the only 2 people left, C and H. So can I say that C and H? Oh, sorry, C is already there. A is already there. I'm left with B, A, B, C, D, and G, F. So E and H are left. So can I say both E and H will be coming at any of these 2 positions, right? Now let's look at the statement. It says that E and H are guided by T. So we know that both of these 2 slots must be filled by either E or H. And you can see that both are guided by T. So yes, E and H, whether E come here or H come here, both of these 2 people will be guided by T. So yes, that statement is correct. E and H are guided by T. G is guided by Q. G is guided by Q. Yes, G is guided by Q. That's also a correct statement. So both of the statement are correct. Answer would be second option, right? Now look at the next question. E and Q are both scheduled in the same slot. Okay, now there's another information that has been given here, and to answer this question, we need to use this information. And to use this information, we need to go back to the standard table and we need to remove the information that we used for the previous question, right? So this will be eliminated, this will be removed, right? This will also be removed, and this will also be removed, right? Now, so here we have G must be guided either by Q or S. F can also be guided by either Q or S. We do not know the person who will be coming over here, and we do not know the person who will be coming over here, right? So that's a standard table. You see that? These are the kind of puzzles which are known as non-unique deterministic puzzle. That means they are not unique answer. They're not. This is not a unique table that we are making. To answer the question, we have to use the information from the questions given, right? Every question also has some information that we need to use, and accordingly we need to answer that particular question. So in these type of puzzle, you need to make a standard table first, right? Some of the information you might not be able to find out uniquely. For example, we know that this is a unique information that nobody else can come over here. This must be C and this must be guided by P. But still this information is unknown, this information is unknown, and then examiner is giving you the more information in the question to handle handle these type of puzzles, right? Where you'll be using the information from the questions, and accordingly you'll be able to fill the numbers here, and these will keep on changing depending on the information of the given questions, right? So always keep this in mind that whenever you're solving a puzzle like this, non-unique deterministic puzzle, you have to use the question's information, right? Look at the question number 5. E and Q are both scheduled in the same slot. I want E and Q to be in the same slot. Then which of the following statement best describe the relationship between D, H and T? Now use this information. If I want E and Q to be in the same slot, E and Q to be in the same slot, okay, now you see that there can be, if I'm taking Q here, then I need to take this person as E. And if I'm taking E here, then I need to take this person as Q. Now both, there will be again 2 more cases, right? Now let's, whether I take E here or I take E here, H is definitely a person which must be coming over here. H will definitely be guided by T, because in both of the cases, whether I'm taking E here and Q here, or I'm taking E here and Q here, H will definitely be guided. H, there's only one space left for H, either this one or this one. So H is definitely going to be guided by T. If I take E here, Q here, then D will be guided by R. If I take E here, Q here, then D will be guided by T and G will be guided by S. So there are further 2 cases. Now let's look at the questions. Question is asking me that which of the following statement best describe the relationship between D, H and T. At least one of D and H is guided by T. At least one of D and H is guided by T. Yes, that's correct. We know that H will definitely be guided by T, whichever case you pick. If I take E here, then I need to take Q here. Then I'll be left with, no, sorry. If I'm taking E here and Q here, then both of either H or D will come here, and also here either H or D will come here. So one of D and H will be coming over here, right? Okay, if I'm taking E here and Q here, then both D and H will be coming here. So depending upon where are you placing E and Q in the same slot, whether you're picking this slot or this slot, one of D and H will definitely be guided by T, and that's the correct statement. And this is what we need to find out. Which of the following best describe the relationship between D, H and T? At least one of D and H is guided by T. That's correct. Both D and H are guided by T? No, that's wrong. Why it is wrong? Because what you can see that in this particular case, when I'm placing E here, Q here, one of D and H will be coming here, not both D and H will be coming here. So you cannot say this statement definitely that both D and H will be guided by T. Either one of D and H will be guided by T, right? So therefore, answer to the question will be first. Neither D or H is guided by T. That's wrong, because you know that one of them will definitely be guided by D or H. Exactly one of D and H is guided by T? No. There can be a case where both D and H is guided by T. So that's not a definite statement. Definite statement is at least one of D and H is guided by T. Right, so guys? So this is the whole set, right? And there's one more information, one more question also. D is scheduled in the slot immediately before Q. Now D is supposed to be scheduled immediately before Q. Then which of the following is not necessarily true? Now let's look at this case. D is scheduled immediately before Q. Now if I want this information to happen, that D is supposed to be scheduled before Q, then you see that if I'm taking Q here, I don't have any slot left for D to be arranged at 10. So if I want D to be before Q, I need to put Q here. And if I put Q here, I need to put D here, right? For scheduling D before Q. If D is coming here, Q is coming here, then S will definitely be coming over here. And then I'm left with E and D, and nothing is given about E and D. So either E or D will be coming at these places. Either E will be coming here or D, and either E will be coming here or D. Now let's look at the statement of the question. Answers, options. G is guided by Q. Yes, G is guided by Q. I'm looking for a statement which is not true, not the reverse, right? So G is guided by Q is a true statement. I'm supposed to find out not necessarily true statement. D is guided by T. Let's look at D is guided by T. D is guided by T. No, D can be guided by T or D can also be guided by R. You cannot say for sure. Sorry, yeah, D is guided by T. That's correct statement, right? Either E or H will be coming here, not D. D is already placed here. We are left with E and H, so either one of E or H will be coming here. D is guided by T. That's a correct statement, right? This is true statement. D is guided by T. F is guided by S. E is guided by R. Let's see. F is guided by S. F is guided by S is true. We are looking for not true. So last option will be the correct, which says E is guided by R. You see that? E is guided by R is not true. One of E or H would be guided by R. We cannot say definitely that E is guided by R. So which other statement is not necessarily true? Answer will be the fourth option. That's a correct statement. So this had 6 question CAT 2020 slot. A very important one based on scheduling. If you know the basics of it, you can easily handle the set in CAT. Here is the set that we are going to cover. It says that XYZ organization got into the business of delivering groceries to home at the beginning of the last month. Now they have a two-day delivery promise. Now keep this point in the mind that they have a 2-day delivery promise, right? However, their deliveries are not unreliable. An order booked on a particular day may be delivered the next day or the day after. For example, if I'm placing an order on Monday, I'll be getting that order either on Tuesday or on Wednesday, right? So there's a 2-day delivery process. So for example, if I talk about the date, if I'm placing an order on 10th of any month, I will be getting that order 11th of that month or 12th of that month. If the order is not delivered at the end of the 2 days, then the order is declared as lost at the end of the second day. So if, let's say, if I'm placing an order on 12th, I'm not getting order by 14th, that order will be considered as lost. XYZ then does not deliver the order, but inform the customer, marks the order as lost, return the payment and pays a penalty for non-delivery. The following table provides detail about the operation of XYZ for a week of the last month. Now this is a scheduling of 1 week of the last month. It's about cumulative orders booked, order delivered on that day, and cumulative orders lost. So that means by 13th of that last month, the total number of orders that have been booked till 13th are 219. And order deliver on day. Now on 13th, now think guys, if I'm delivering an order of 13th, that must be placed either on 11th or on 12th because it's a 2-day delivery process. So on 13th, I'm delivering 11 orders. These 11 orders must be of the date of 11th or of 12th. And total number of orders which have been lost till 13th are 91, right? Now, when I go to the 14th, you see that the total number of cumulative orders booked are 249. So can I say that the difference between these two is of 30? And this gap of 30 is basically telling me that by 14th, the total number of orders are 249. So can I say on 14th, the number of orders placed are 30. If I'm specifically talking about this date, there will be 30 orders that will be placed on 14th, right? Orders delivered on 14th are 27. Now tell me, think guys, if 27 orders are delivered on 14th of a month, can I say that these 27 orders must have been placed on 12th or on 13th, right? So because it's a 2-day delivery process. Now you see that total number of cumulative lost are 92. Now there is an increase of 1 in the order lost. Now when do you count an order as a lost order? When the delivery does not happen after 2 days. So can I say that if on 14th I'm increasing the cumulative order lost by 1. If I'm increasing the cumulative order lost by 1, can I say that this lost 1 order, the order that I'm losing here, the 1 value that I'm losing here, the one order that I'm losing here must be from the order that must have been placed on 12th. This lost must be from the order placed on 12th, because if I'm counting it on 14th, that means the order which have been placed on 12th and still not delivered till 14th will be counted as lost. So this one increment must be of 12th date, right? So this is how you are supposed to read this complete table, make a full table to answer all the question, and it's very, very tricky. You have to find out what are the number of orders that are placed on each of these dates to answer the set. Then you also need to find out of the orders of a particular date, how many orders are placed, how many orders are delivered on the next day, and how many orders are delivered on a gap of 2 days. So for example, if I'm saying that 30 orders have been placed on 14, out of these 30 orders, I'm supposed to find out how many orders have been placed on, how many orders have been delivered on 15th, how many orders have been delivered on 16th. That's something that you need to find out to answer all the set. And there's an information here. It is known that the number of orders that were booked on 11th, 12th, and 13th of the last month that took 2 days to deliver were 4, 6, and 8. That means all the orders that I am placing on 11th, out of all the orders that I have placed on 11th, 4 orders have taken 2 days delivery time. That means these 4 orders must be delivered on 13th. There's 6 such orders which I am placing on 12th, but they are taking 2 days to deliver. So that means these 6 orders must be placed on 14th of that month. 8 orders have been placed on 13th and it takes 2 days to deliver. So can I say that on 15th I'm ordering this? On 15th these 8 orders have been delivered. Now this is the table that you have to make to solve the whole set. Write down the name of the day, right? The date of the days, right? And then cumulative order booked as per the given the table, right? These are the values that I have taken from this table as it is. I'm just adding 2 more days here, 11th and 12th, because I have an information regarding 11th and 12th, how many orders placed on 11th are taking 2 days, how many orders placed on 12th are taking 2 days. So you need to make this column. Then you need to find out what are the number of orders which are placed on particular day. Orders delivered, how many orders have been delivered on that particular day has already been given in the table, right? So I have taken these values from this. But what I need to find out is how many orders are delivered on n+1 day and n+2 day. This is the column I need to fill in to answer the question. And cumulative order lost were given to me. I will be now finding this lost, right, which is happening is of which day, right? For example, here the increase of 1 is a lost of 12th day. So we will be counting it, right? So we have to find out this column also. Now, first of all, where should I start solving the set from? You can start solving the set from here directly. On 13th, my cumulative orders booked are 219. In 14th, the cumulative order booked are 249. So can I say the increase is of 30, and the increase of 30 is nothing but the number of orders which are specifically placed on the 14th of that month. Next, 14 to 15, the number of orders are getting increased by 28. So can I say that these 28 orders are placed on 15th of that month? Then you go further, the increase is 25 and the number of 25 orders are placed 16th of that month. Then again, there's an increment of 25 in the cumulative order. So these 25 orders must be placed on 17th of that month. Then there's increase of 5. This would be of 18, and increase of 5 again, this must be of 19. Okay. Now the information given is that the number of orders which I'm placing on 11th, out of those order, right, 4 orders are placed on n+2th day. That means if I'm placing an order on 11th, that order will be delivered on 13th, and that number of orders are 4. Okay. And if you look at 12th, the number of orders given are 6 as per this statement. I'm using this information. The number of orders placed on 12th, delivered on 14th are 6. Number of orders placed on 13th and delivered on 15th are 8. Now, you see that if I look at the number of orders of 13th, there are total 11 orders which are delivered on that day. Now just try to think these 11 orders which are delivered on 13th, these orders must be coming from, must be placed on 11th or 12th because it's a 2-day delivery process. So all these 11 orders must be, some of these orders must be from 11th of that month, some of these orders must be from 12th of that month. Now look at here. Out of all the orders that I'm placing on 11th, 4 orders have been delivered. 4 orders are taking 2 days. That means these 4 orders are delivered on 13th. So can I say that out of 11, can I say that 4 are the orders of 11th? So can I say that rest of the 7 orders must be of 12th? So out of all the orders which I'm placing on 12th, 7 orders are delivered on next day, and 6 orders are delivered on 14th, and there is a lost counted of 1, and this lost must be of 12th day because a lost is counted, an order is counted as a lost order when it is not delivered after 2 days. So if on 14th, if my order lost is getting increased by 1, this must be of 12th because the order which is placed on 12th, and if it is not delivered till 14th, it will be counted as lost. So if there's an increase of 1, so can I say this is a lost order of 12th of that month. So how many orders are placed on 12th? 7 plus 6. 7 are delivered on next day, 6 are delivered on 14th, and 1 is lost. So total, can I say that on 12th, can I say the number of orders placed are 14? Yes, the number of orders placed must be 14. Now if you look at 13th, look at here guys. If I look at 14th now, out of 14th, you see that the number of orders delivered on that particular day are 27. And the 27 orders which are getting delivered must be of these 2 days, 12th and 13th. Now, I know that there are 6 orders of 12th which are taking 2 days delivery point, 2 days delivery time. So can I say out of these 27, 6 are the orders which are placed on 12th. So can I say rest of the 21 must be the orders which are placed on 13th but delivered on 14th. So these are taking 1 day to deliver. So I will be writing down the value 21 here. That means they are taking 1 day of delivery time. Now, when I'm moving from 14 to 15, the number of increase in the lost is 2. Now tell me which order will be counted as a lost order on 15th. Order which are placed on 13th, not getting delivered till 15th will be counted as lost. So can I say there's an increment of 2? So there will be a lost of 2 orders on 13th. Now out of all the orders placed on 13th, 21 are delivered on the next day. That means on 14th, 8 are delivered on 15, that means taking 2 days, and 2 orders are lost. 21 plus 8, 29 plus 2, 31. So can I say on 13th, order placed must be 31, out of which 21 are delivered on the next day, 14th, that means 8 are delivered on 15th and 2 are lost. So now if 219 are the cumulative orders booked and on 13th I have 31 orders placed, so can I say till 12th, the number of orders must be 219 minus 31, 9 minus 1, 8, 11, must be 188. So till 12th, the cumulative order must be 188. And out of 188, 14 orders are delivered on 12th. So till 11, the number of cumulative orders must be 188 minus 14. That means 174, right? Okay. So we got this column completed, this column completed. We need to complete this column and our job will be done, and that's it. We are done with this set then. Now look here guys, on 14th, you see that we have taken care of all these 27, right? Out of these 27, 6 are of 12th, 21 are of 13th. Now look at 15th. On 14th, the number of orders that you're placing are 30. Can I say that out of these 30 orders, some of the orders will be delivered on 15th and some will be delivered on 16th. Now, order delivered on 15th are 23. Now, the orders which are delivered on 15th must be placed, some of the order must be placed on 13th, some of the order must be placed on 14th. I know that there are 8 such orders which are placed on 13 and taking 2 days delivery time. That means these 8 orders must be delivered on 15. So can I say out of 23, 8 orders are from 13. So the rest of the orders, 23 minus 8, that means 15, must be of 14th, right? Now 30 orders are placed, 15 has been delivered on 15th, right? And then if you look at the increase in the number of lowest order, when I'm going from 15 to 16, the increment in the number of lowest order is given to me as 6 plus 6, that means 12. And these increment of 12 is because of the 12 orders which have been lowest, and these 12 orders which have been lowest must be of 12th, right? Or must be of 14th, because these 12 orders which are placed on 14th, not delivered till 16th, will be counted as lost. Now, look at these 30 orders. Out of these 30 orders, 15 have been delivered on the next day. We have already seen it. Some will be delivered on 16, but we don't know that value. Out of 15, 12 are, out of 30, 15 are delivered, 12 are lost. We are left with 3 more orders. So can I say that 3 such orders of 14th which are delivered on 16, that means they are taking 2 days delivery time, right? They are taking 2 days delivery time, right? Correct. Now let's move further. On 15th, I have 28 order placed. Now, total number of orders which have been delivered on 15th are 23, out of which 8 are from 13th and 15 are from 14th. 8 plus 15, 23. We have already sorted out this thing. Now, look at the value of 16. 11 orders are getting delivered on 16th. Can I say the orders which are getting delivered on 16th must be placed on 14th and 15th? Some of the orders must be placed on 14th, some of the orders must be placed 15th. I know that all the orders out of 14, 3 orders out of 11 are of 14th. So rest of the 8 orders must be placed on 15th. So total 28 orders are placed, out of which 8 are delivered on the next day. Some will be delivered on 17th, but we don't know that value. But we can see that the increase in the number of lost is 12. So can I say that these 12 increment of the lowest order must be because of those orders which are placed on 15th, because they are taking 2 days and still not getting delivered, so will be counted as low. So these 12 orders will be coming here at 15th position, right? Now look at here, guys. Out of 28 orders which are placed on 15th, 8 are delivered on 16th, 12 are counted as lost. How many I'm left with? 8 plus 12, 20. I'm left with 8 more orders. So 8 more orders of 15th must be delivered on the next of the day. That means on 17th. Now, out of 21 orders which have been delivered on 17th, I can see that 8 orders are of 15th. So can I say rest of the 13th order must be of 16th? Rest of the 13th order, 13th order must be of 16. Now 25 orders are placed on 16th, 13th are delivered on the next day, that means on 17th. Increment in the lowest is of 2, so these must be the lowest of 16th orders placed. So out of 25, 13 are delivered, 2 are lowest. I am left with 10, so those 10 must be delivered on 18th. Out of 13 orders which are delivered on 18th, 10 are coming from 16th. Rest of the 3 order must be rest of the 3 order must be of 17th. Out of 25, I have 3 orders getting delivered on the next day, that means on 18th, right? And on 19th, the number of lowest order are getting increased by 9, so this must be a lowest of 17th day order place. Out of 25, 3 are delivered on next, 9 are lowest. 9 plus 3, 12. Out of 25, I know what is happening with these 12, so rest I'm left with 13 more orders. So can I say this will be the value that will be coming over here? So out of 25, 13th order are delivered on the 19th, right? Now out of these 14, I know that 13 are coming from 17th orders place, right? So 14 orders which are delivered on 19th, 13 are placed on 17th. So I'll be left with 1 more order. and that one order must be of 18th, right? Now I don't have any more figure to identify how many are lost. So I will not be able to fill in this information, right? So out of 5 orders which are placed on 18th, one is getting delivered on 19th. What is happening with the rest of the orders? We do not know, because we do not know what is happening with the lost, right? That's it. This is the complete table that you have to make to answer all the questions now. We now know how many orders are getting lost on a particular day, how many orders are delivering on next day, how many are taking 2 days to deliver time. Now you can answer all the questions. Let's have a look at the first question. Question number 1 says, among the following days, the largest fraction of orders booked on which day was lost? So how many was booked and how many was lost? So where is the largest fraction out of all the orders which are booked and the orders which are getting lost? So lost as a percentage of booked is largest in which number? 15, 16, 13, 14, 15, 16. If I look at 13th, 31 order are placed and out of which 2 are lost. So on 13th, I have a fraction of 2 by 31. If we look at 14, 30 orders are placed, 12 are lost. 12 out of 30 are lost. So that's a fraction of 14. 15 and 16. 15, 28, 12 out of 28 and 2 out of 25. 12 out of 28 on 15th and 2 out of 25 on 16. So if I have to compare the fraction, I can see that these are straight away eliminated. The fight is only between two fractions, that is 12 by 28 and 12 by 30. Again, there's no fight. The denominator here is small, so this value will be more than this. Numerator is same, but denominator is small here. So on 15th, the number of orders lost as a fraction of total orders booked is highest in 15th. Right. 15th is the right answer. Let's look at the next question. On which of the following days was the number of orders booked the highest? Number of orders booked. Okay, so I'm supposed to tell in which particular day highest number of orders are booked. The highest number of orders are getting booked. You can see that on 13th, right? The placed number of orders, the highest number of orders getting booked are on 13th. So 13th will be the correct answer of the question, which is option number 4. Let's have a look at question number 3 now. It says the delivery ratio is just a calculation based question, right? Our job is almost done. The delivery ratio for a given day is defined as the ratio of the number of orders booked on that day, which are delivered on the next day, to the number of orders booked on that day, which are delivered on the second day after booking. On which of the following day was the delivery ratio the highest? So delivery ratio for a given day is defined as ratio of the number of orders booked on that day, which are delivered on the next day. So basically the number of orders which are delivered on n plus 1 day and the number of orders which are delivered on n plus 2 day. That's my delivery ratio. And I'm supposed to tell which in which of this day delivery ratio is highest. Now I can see that on 13th, if you look at, on 13th, n plus 1 upon n plus 2 is 21 by 8, right? On 13th, this value is 21 by 8. On 14th, 15 and 16, let's check it. On 14th, 15 and 16, 15 by 3, 8 by 8, 13 by 10. 15 by 3, 8 by 8. 15 by 3, and this is 8 by 8. Sorry, 15 by 3 is of 14th. 15th, it is 8 by 8. If I talk about 16th, it is 13 by 10. Now tell me, where, in which particular case the delivery ratio is highest? You see that this is 3 by 50, 15 by 3 is 5. None of the fraction is close to 5. So the answer will be 14th. 14th, it is 15 by 3, right? 14th, it is 15 by 3. So on 14, it is highest. That would be the correct answer of this question. This question came in CAT 2020 slot 3, right? A beautiful set, guys. Very, very important one. Now let's look at one more question, question number 4 of the set. It says, the average time taken to deliver orders booked on a particular day is computed as follows. Let the number of orders delivered the next day be X and the number of orders delivered the day after be Y. That means if if the number of orders delivered on n plus 1 is x and the number of orders delivered on n plus 2 is y, then the average time to deliver the order is taken as x plus 2y upon x plus y. Now I'm supposed to find out on which of the following day was the average time taken to deliver the orders booked the least. So 13, 14, 15, 16. Let's write down the values first. 13, 14, 15, 16. 13th we have 21, 8, 14, 15, 3. 21, 8, 15, 3. 21, 8, 15, 3, 13, 14, 15 and 16. 15th we have 8 by 8, 16 we have 13 by 10. 8, 8, 13, 10. 8, 8, 13, 10. Now if I apply this formula which is given to me in the question, n plus 1 value is this first value written in the bracket, n plus 2 value is the second value written in the bracket, x plus 2y upon x plus y. Now x plus 2y, 8 plus 2 into 8, that means 8 plus 16 upon x plus y, that means 16. That is 24 upon 16, which is 3 by 2, which is 3 by 2, which is 1.5. 21 by 8. Now if I look at this fraction here, this would be 21 plus 2 times of 8, that is 16. 21 plus 16 would be 37 upon 21 plus 8, 29. 37 upon 29. If you look at this value, 13 plus 2 times of 10, which is 20 plus 13, 33 upon x plus y, that is 23. If you look at this fraction, 15 plus 2 times of 3, that is 21 upon x plus y, that is 18. I'm supposed to find out which fraction is least. This you can see that 3 into 7, 7 by 6. 7 by 6 is, it would be 1.16 something. This is 1.5 something. If you look at 37 by 29, it would be 1 plus 37 and 29 have a gap of 8, 8 by 29. Okay. And this is 1 plus gap of 10 upon 23. Now, if I have to compare these values, you need to be very comfortable with the fraction. Now, 1 upon 23 is 4.34. If I multiply 0.0434, right? Or in terms of percentage, 1 by 23 is 4.34. Multiplying it by 10 would be 43.4. So the final would be coming out to be 1.434, right? This would be the fraction. If I look at this fraction, 1 plus 8 by 29, 1 by 29 is 3.45. And if I look at 8 by 29, this would be 8 times of it. 8 into 5, 40. 4, 8 into 4, 32, 32 plus 4, 36, 3, that is 27.60. So this comes out to be 1.2760. So if I have to find out the least fraction out of these, this is 1.5, 1.2760, 1.434, and this is 1.16. So 14th, you can see that this fraction is the least value. So the answer to the question is 14th. You can cross verify once again the calculation part. Main part was to make the table. Just cross verify the calculation. I'm doing it live here in front of you. There might be some error, but I'm 101% sure the answer should be 14 to this. Just again cross verify it. If there is any correction, I'll let you know in the comment section.